Hello, everyone. This is Irvin McFadden. I'll be your host today for today's Analytics and Data TechCast. It'll be immediately following after this introduction. Just a little bit about myself. I am a senior BI consultant with US Analytics, a member of the board with BWA User Community, which is made up of volunteers. And we also present the Analytics and Data Summit TechCast. So today we're having a great speaker, Charlie Berger, who is the product manager for Oracle Machine Learning and a co-founder of BWA User Community. Today's presentation will be the changing role of DBA from database developer to data scientist in 6 weeks. After Charlie's done, we'll have a brief question and answer session. I ask that you put your questions during the session into the Q&A section. And you should find that or the chat section, but we prefer the Q&A section. Before I hand over to Charlie, I just want to make an announcement that our next upcoming TechCast was scheduled for December 19, which is Planning My Summer Vacation Using Python Machine Learning and Oracle Cloud, presented by Brendan Tierney. I'm going to let Charlie introduce himself. And without any ado, I'm going to go ahead and turn it over to Charlie.
All right, thanks, Irvin, for that introduction. Hello, everyone. Thanks for tuning in on this Thursday TechCast in our TechCast series. My name is Charlie Berger. I'm the Senior Director of Product Management for Machine Learning, AI, and Cognitive Analytics. And I will be talking about something I think is pretty cool for this audience. And by this audience, I think they're probably mostly Oracle technical professionals of some sort. And it's going to be about, this changing role of the DBA as we go through the autonomous database and, just technology over the years, that it is sort of evolving. And I have this theory that is based on observation. That I've seen many database developers or data professionals, people that know the Oracle database technologies and SQL and all of that I've seen them evolve to become data scientists. I've worked with them, I've supported them, I've trained them. So what I'm going to do here is outline a very practical, pragmatic pathway towards becoming a data scientist, and I would say adding data science, machine learning skills to your valuable repertoire of SQL and data management skills. So I think it's a very natural evolutionary path, and I'll go through this. Now, some people have asked, hey, is this a course? Where can I sign up? And I'm going to anticipate that question now. Right now, it's this webinar that you're watching and some hands-on labs and some tutorials and various things that are out there on the internet. They will point to some of those. But I'm also working with Oracle University to try and assemble this into a 2-day course. So that's something that we're working on right now as we speak to formalize some of the things I'm doing a little bit of hand waving on in the TechCast. So with that, let's continue on into it. We always have the safe harbor statement that talks about the disclaimer about any statements I may make about futures. I do make a couple of statements about futures, so we always have to show that. Now, I got this slide from Andy Mendelson, who's our Executive Vice President of Data Management, database development, that is. And he presented this, and I liked it because from his point of view, and I think Oracle's point of view all around, is that our most critical asset is data, your valuable data, and it's to manage, protect the world's data, for the benefit of all. And if you have that data, then you can do a lot of things with that data. And from my machine learning point of view, that's where I sort of start. Now, again, other people at Oracle can talk to this much better than I can, but from the autonomous database launch, and that's been one of Oracle's most successful launches, maybe the most successful as far as I understand. One of the things that's been observed is that today, DBA spend a lot of time on maintenance and innovation. They do maintenance, security, reliability, patches, things like that. And with the autonomous database, more and more of this is automated because the autonomous database's key features are that it's self-driving, it's self-securing, and it's self-repairing. And I'll let other people talk about that in much greater detail than I'm going to try to attempt to cover now. But if you've been tuning in on the Oracle Autonomous Database channel much, you'll see this and many proof points and success stories and so on. And I like it from a data scientist type of point of view in that I could just fire up an autonomous database in about 3 minutes. I tweeted it at Oracle Open World when Larry Ellison announced that they were free for everyone now at the always free tier, which includes the machine learning. On my way up Moscone West escalators, up 2 flights, I registered for an autonomous database account and launched it and was driving the autonomous database, including all of these machine learning algorithms that I'm going to talk about. Now, also, I should say that the machine learning algorithms that I'm going to talk about are not only in the autonomous database, they're also in every enterprise edition of the database, be it on-premise, in the cloud, wherever it is, they're all in there. But in the autonomous database, they're also free, and that's something that is easy to access, I think. So that's one of the exciting parts of this. So how will the autonomous database change things? And there are some presentations and slides that I'm borrowing from here that says, well, today, the specific tasks the DBAs do is architecture planning, data modeling, data security, maintenance tasks, database provisioning, patching, and so on. And that because of that, there's a lot of maintenance type of features, and that the autonomous database eliminates a lot of the basic maintenance tasks, so you don't have to do those anymore. And what that does is it frees you from this drudgery, and it gives you much more time to apply your knowledge, your domain knowledge, and all your valuable SQL and data skills to do more with that data. So I think it's a huge opportunity, and it's a very natural evolutionary path for DBAs. And I don't mean just purely DBAs. I mean database developers, IT professionals, BI analysts. I'm going to call them Oracle data professionals, okay, as a kind of a catch bucket for anyone that can kind of spell SQL, knows their business's domain, is analytically curious, and I always say, if you know the difference between a mean and a median, you are a candidate to be a data scientist. If you either don't know or don't care, then maybe it's not exactly your area. But if you're trying to find, meaning from data through some sort of analysis, and you have a lot of SQL skills, then you're right in the wheelhouse for, I think, where you can continue forward by adding some machine learning skills to your area. Now, again, also from my background, I didn't go into a whole lot of detail, but I've been doing this for a long time. 23 years with Oracle and the previous company, Thinking Machines, that was acquired, but 9 years before that at a statistical analysis software, Bolt, Beranek, and Newman was called. And what I've observed over the years was when you're doing statistics, you had to be a PhD statistician. You had to know exactly which statistical technique you're going to use and so on. Machine learning sort of automates a lot of that stuff, right? It says, I have algorithms that you serve up the right problem, the right data, and the algorithms kind of do a lot more automatically. And that's what makes it sort of more approachable to more people. And makes it exciting. So what Oracle have done over the years is what we say a lot is we move the algorithms, not the data. Now, if you look over the right, that's a naive Bayes algorithm, and what it does is it basically just counts things. How many times did the person who bought the hybrid car, were they a male, were they a female? How many times did they rent or did they own, and so on? And that kind of technique lends itself to an in-database implementation. So all of the algorithms that we have are written in C code. I don't want to imply that I wrote all the algorithms. That's not true at all. I work with about quite a number of PhD, very smart database algorithm developers, and what they do is they implement neural networks, decision trees, random forests, clustering algorithms as native implementations inside the database. They write them in C code along with all the rest of the database code. They generate the algorithms. We're not sort of running R or Python in the database. We can integrate with that, and we do that, and you can use R or Python syntax to call these same algorithms, and you can use Oracle Machine Learning to make callouts to R and Python. But the real secret sauce here is that we have quite a few algorithms for clustering, regression, classification, text mining, and attribute importance, anomaly detection, statistical functions, and they are exposed and accessible via SQL, GUI, Notebook, R, and very soon in early 2020, Python. And when you add all of these algorithms, also forecast, and I see up there, also when you add all these algorithms, it transforms the database into what I think is more of maybe it's called an AI database, maybe it's a thinking database, but it really changes everything. You don't have a dumb file cabinet that's storing your data waiting to have it exported over some sort of other analytical engine. You can do all that inside the database. So what we have for an offering is called Oracle Machine Learning. You may know it by Oracle Data Mining, Oracle R Enterprise, Oracle Advanced Analytics. We've done sort of a soft rebranding, remarketing, and everything falls under the higher level of Oracle Machine Learning. Oracle Machine Learning for SQL is mostly what I'm going to talk about, and the notebooks and the data miner because I'm thinking I'm primarily pitching to a Oracle-centric. But if you also speak Python or R or Spark or have microservices, we want to use microservices, we have all that as well. So inside the database, we have quite a toolkit, I guess, of parallelized implementations of machine learning algorithms. And what's clipping off the bottom, I just noticed here, is the fine print that says, by the way, these are all in database implementations. So if you want to build a generalized linear model for predicting who's going to vote for the Republican or the Democratic candidate, and you want to partition by state or partition by gender, that's just a partition by clause. If marital status is a clob and it's a whole paragraph, well, we use Oracle text under the hood to tokenize all that text and bring in a whole vector of terms that are brought in as nested tables into the analysis. So the main point here is we have quite a respectable, I think it's hard to use the word complete because, there's always a new algorithm being developed, but of the main powerhouse algorithms that most people use most often, I think we have them all covered. Some people may say, well, where's XGBoost? Well, that's one of the ones that's coming in the 20C release and will come to autonomous. We also have something called MSET SPRT, which is a process monitoring algorithm that's coming, and so, other cool things that are coming. But we have a pretty complete toolkit. We also have quite a range of statistical functions, t-test, f-test, and so on. So you take this whole analytical capability and you move the algorithms to the database, and it opens up a lot of possibilities. One is just the pure performance of these is astounding. If I look at, say, this generalized linear model regression on a 512 degrees of parallelism exadata with 640 million rows and 900 attributes, we're getting results in a minute. Okay, and you think about just how fast it is and what kind of open doors that opens up for you to, as a data professional, like, wow, I could build, a model on all of the data I have and make a prediction for every variable and serve up reports that show the difference in actual checking account or savings account balance versus the predicted value. And you could just, do many, many creative things. So what I'm here to also do, I think, is hope to inspire you to go off and apply these things and do more with your data, because it's very, very powerful. So in sort of summary of what we have, and we'll switch over to how you evolve, we have quite a range of algorithms that are native implementations inside the database. We also have capabilities that run outside the database, but more importantly, I think we also have at the bottom the big data SQL, Cloud SQL it's also called, that help you sort of boil down some of that data, join it to the other data, and then you can use R, you will be able to use Python, you can use the drag and drop Oracle Data Miner GUI that comes with SQL Developer, you can use the new Oracle Machine Learning Notebooks, and with this, you can do a lot of things. So, as a data professional, how can I prepare for this? Well, one is to realize you're probably already doing most of this work today, and there's very many studies that's clipping down at the bottom here for some reason, that typically 80% of the work is data wrangling, data extraction, data preparation, and my experience is, hey, I could try to do that in R, I could try to do it in Python, or do it in a drag and drop GUI or something outside the database. But it really is nice when I can go down to the DBA and say, hey, can you give me a count of how many times the person submitted the tax form, or how many submissions came from that IP address? I'm looking for possible fraud. And a lot of those cleverly derived variables that are based on your domain knowledge and your knowledge of the business problem, well, they're oftentimes, most often, implemented as SQL. So you may be being asked to do all this work, and I have some number of different stories and examples I can tell where the DBA said, oh, wow, I didn't realize I'm doing all the work. All you're doing at the very end is this little part in the middle where the magic happens, and I'll show you what that magic is. It's not, I don't think, that complicated. But then let's say the data scientist uses, R, Python, Data Robot, SAS, you name it, some other, TensorFlow, some other package or platform out there to build a model, and they say, hey, Charlie, I got this really good model. I'd like to operationalize that now. Well, how do you do that? That is written in another language. It's another foreign object kind of platform. And if this is all just a script inside the database, you can build it in one database, you can deploy it on the same database, you can move the scripts and the logic to another database instance, and off you go. It just is a much smarter, simpler sort of analytical platform. So when you do machine learning, there are these well-accepted industry standards for 20 or 30 years, CRISP-DM, cross-industry standard process for data mining, it was called back in those days. And it just says you should know your business understanding. You should know your business. What are you trying to do? Data understanding and so on. And I sort of outline a logical path that says, I think you can absorb and digest the nuances and the complexities and what's going on in each one of these things. It's kind of like, learning to ski. Let's start on, the bunny slope and then learn how to turn, learn how to stop and keep on going. And by the end, you're sort of skiing down from, at least mid-mountain, maybe higher up. So let's go through what this means. And at the end, if you do all this, then congratulations, you're a data scientist, my contention. So most people, when they talk about analytics maturity, they talk about, where did the data come, what happened in the past, why did it happen, and maybe they do some sort of prediction and they say, eureka, hurrah, I built a predictive model. But that's where we sort of start, because what we do is we say we build the models, but what you won't see on most vendor slides is this automated machine learning applications, pipelines of analytics, deployment, production, and Oracle currently undergirds many larger enterprise applications and operations. And when you bring the algorithms to that platform, it just opens all these doors so that whatever you've done can be immediately operationalized. And this is corroborated by a few different stories out there. This is one by Fern Halper that did a study of how long does it take to build a predictive model? And once the model is originally built, how long does it take to define them, to take a defined model and operationalize it? And if you look at this, something like 65% are saying 3 months to maybe never. And so now this is my editorial comment. They must be using sort of legacy external platform, kind of analytical platforms like that, because if they were using Oracle, by definition, you're just building and applying the model inside the database. What could be simpler? So again, this is Fern's slide. This is my editorial comment. I want to be very clear about that. So what's going on under the hood? It's just SQL. It's just SQL functions like sort, rank, partition, group, whatever. But now we're calling statistical functions. I always like to show this first because these are a bunch of the statistical functions we snuck into the database way back in 10GR2. And I find a lot of people say, oh, you're doing a t-test or a Pearson's correlation. I get it. I understand that. I took that in college. I know what that is. I can see the syntax, and that makes sense to me. So I always like to start out with this for sort of a logic leap. Now let's go over to building classification models. Well, here I'm building a classification model, so I'm going to try and predict who buys a hybrid car, who doesn't, who defaults on a loan, who doesn't, who shows up for a medical appointment, who doesn't show up. And so now I have the syntax, begin DBMS data mining, create model. Now most people that I always ask, do you read a little bit of SQL and can you read this? Can you see what's going on here? And they usually quickly nod and go, yeah, I get that. So we're building a model called buy insurance. We're doing a function, a type of model classification. There's my target, there's my data table name. That could be a table or view or an assembly of several things. But when we press go to build the model, and this will happen, this would take 1, 2, 5, 10 seconds or so to build the model, maybe a minute. Then I've predicted the buy insurance. I have my settings table here, and there's other different settings we have, including auto data preparation. But once that model is built, it's just buy insurance. I can even use with these values. So you can now imagine some sort of widget that says, oh, the age is not 22, it's 42, or whatever. You can kind of correct that and get a new score immediately because it's just a real-time apply. If I were to do a different type of function, an attribute importance, well, here we show it as an attribute importance. It's the same sort of syntax, and notice we get 0.2161 for the importance or rank of these variables. If I wanted to use a different language, because data science is a sort of a team sport, some people speak R, some people speak SQL, that same function call is now coming in from an R syntax because we wrap and expose these algorithms with the open source R language. We also make callouts and integrate, so you can also call out R, but in that case, sometimes you're paying a penalty because you're moving the data out to R to do that. But you can do lots of things with that, and we're coming in with the ability to do the same thing from the Python language that'll come in early 2020. So now, continuing on, you have a number of different languages, but we're going to now sort of switch gears a little bit into introducing the Oracle machine learning notebooks that come in the autonomous database. So the notebooks are Zeppelin-based. They're a collaborative user interface for data scientists, data analysts, application developers. Currently, the notebooks only speak SQL, but as I've said a few different times, in early 2020, we'll add Python, and then after that, we'll add the ability to do R. And we also have, what I'm going to show here mostly is code, right? Under every good GUI, there's code, and as we build this out on the Autonomous Data Warehouse Cloud, what we have is the code to do things, but we're also, as I'll show in a minute, doing GUIs to automate this as well. On-premise or in database as a cloud service, of course, you have SQL Developer, and a lot of people know and use SQL Developer. We also have the Oracle Data Miner add-in user interface. It's been out there, but not a lot of people have seen this because they're not really aware that Oracle has machine learning. But now, as there's been across the industry sort of more of awakening, a lot of people are saying, "Oh, wow, look at that! I already have that, and I can do a lot with that." And this is designed to be for the citizen data scientist or just somebody who doesn't want to have to write code to do everything. And it also generates SQL code as an output for helping accelerate the deployment. And so I just like to use those different steps about business problem, data preparation, and so on. That was in that crisp DM model. Well, we have nodes for all that, right? Business understanding, we're going to try and build a model of who's likely to buy insurance. We're going to do data understanding. We're going to do data preparation. So we have transform nodes. We can also call SQL when we whatever we want. When we do our modeling, the modeling and evaluation is all packaged in this very sort of powerful, it's not just a bunch of atomic level functions. There's sort of more of a molecular level of a number of things that go on there. We do our training and testing is all built in there. When I want to apply the model, it's just an apply, or I can generate code. So the workflow sort of shows that. You can also, underneath that, every GUI is code, and I'll show you how we do that code today and how we're adding the new GUIs and so on. So let's talk a little bit more about the journey. And by the way, this is going from this is supposed to be going from a cocoon to I guess a pretty butterfly there at the end. So good luck with all that. So what is machine learning? Well, depending on what you're trying to do, you could be identifying the most important factors. That's attribute importance. You could be what I've mostly been talking about and what most people do, predicting an outcome, predicting customers likely to default on a loan, people likely to buy something or whatever. And depending on what you're doing here, there are different kinds of things. There's supervised learning and unsupervised learning. So in the first week, we talked a little bit more about what is machine learning, what are the different types of machine learning, and how we apply these concepts to business problems. So let's keep going here. We're going to talk about the major steps: business understanding, data understanding, and so on. So here's business understanding. The most important thing is start with a well-defined business statement, something like predict employees that voluntarily churn, predict the customers that are likely to churn, target my best customers, and so on. How can I combat fraud and so on? Well, these are all, and the worst one at the bottom, I've got all this data, can you just mine it? That's a terrible thing to do. We can go on forever about that. So I always like to think about Albert Einstein's statement. If he's asked to solve a problem, he's going to spend most of his time thinking about the problem. Like, am I trying to save the planet? Am I trying to save all the men, women, and children, or just the children? Am I trying to save the planet for 5 minutes as a comet goes by, or am I trying to save it for eternity? And depending on the definition, you might come up with different solutions. So let's go through some of those other questions. Predict, and this is the most important thing. That's why I think it's so approachable, so logical that data professionals just keep going with their powerful data skills, just add in that incremental machine learning. So predict employees that are likely to leave, target my best customers, not so well defined. Better defined is target my best customers who has spent more than $500 in the most recent 18 months, or predict employees that are likely to leave based on past employees that have voluntarily left. Create a new variable. This is something you would probably do. You'd be asked to do this, and flag them as a 0 or 1. And so this goes on and on. Once I've categorized these into, and I've sort of shaped the problem into the form of a machine learning kind of thing, then those naturally map into certain machine learning functions: classification, regression, association rules, and so on. So this is still part of week 1, kind of concepts of my thinking is, it's like learning how to play guitar or whatever. You learn how to ski, you learn new skills, and it takes you a while to kind of grasp this and wrap your brain around it. But that's the most important problem, as everyone will say, including me. So here's one of the ones we have in our hands-on labs: to target the best customers who have good credit and keep making their payments. They can keep up with their payments. So if you use now I've switched over to the Oracle Machine Learning Notebook, which I'll show probably mostly. And in here, as I visualize this data, select customer ID and take a representative sample of the data, I'm looking for people that have good credit. I want to find more people like this. So the next thing I want to do is look at the data. Does the data make sense? Whether I'm looking at this in SQL Developer, or Oracle Data Mining workflows, or Oracle Machine Learning Notebooks, I want to see the data, and I want to see, are ages all positive values, are income all weekly values, or monthly, are the loan amounts reasonable, et cetera, et cetera, et cetera. So this is a very, very important step. Garbage in, garbage out totally applies. And you can use the Oracle Data Miner GUI to do the same sort of thing. We just run the same statistical functions, and we graph it, and you can visualize it either in the notebooks or on-premise, or use R, or very soon use Python. We're back to Oracle Machine Learning Notebooks, where they have the Zeppelin allows us to do some nice, simple, basic bar charts, pie charts. And again, I'm reviewing the data. Does it make sense? And this is such an important sort of data hygiene kind of thing that you have to do. Also in data understanding, there are a lot of automatic data preparation techniques that we do for handling missing values, outliers, binning. We also have attribute importance that'll tell you what are the variables that are most important, how many have unique, too many uniques, too many constants, and we'll even suggest these things don't seem to make much sense. Do you want to take them out and you turn them off? You click them off out of there, and you can do this via the GUIs, via the notebooks, via the code, whatever you want to do. But we do a lot here, which is trying to automate things quite a bit. And in the data preparation, I want to kind of point out that you know, a lot of times things are basic. I ask for what's the age of the person. There's not a field that says age. There's a field that says date of birth, and somebody has to convert that. So address, I may have an address, but I may want to use Oracle Spatial and Graph to say, well, how far is it from here to there, or how long is the commute to go to there? If I use SQL patterns, I might want to count the number of dropped calls, and more interestingly, figure out the number of dropped calls in the past month versus the previous 6-month average. And all these like cleverly derived variables help you to do better and better analysis. I guess I have a duplicate slide here. I forgot about that guy. The main point here also is, hey, by the way, do not move the data. You don't have to do that. You can do all of this analysis, the model build, the model score inside the database. So, and when doing so, you save lots and lots of times. And all of our customer references are basically, you know, kind of talk to that fact. I always like James Taylor and Neil Radon's book that says the wrong way to get your data together is to catalog, you know, look at the schema. Here's all the data I have. Charlie, can you use this data? Wrong. That's not the good way to do it. The right way to do it is figure out what your business problem. I'm trying to figure out, you know, employees that are likely to voluntarily leave the company. Well, what would be the data I'd want to know? I'd want to know their salary, their bonus amount, maybe compared to peers. I want to know how long they're working for manager A or manager B. How much travel are they doing? What's the difference in travel? And of course, you know, all their benefits. What's their benefits plans, and how do they use that? So you really want to think about what's the data I want to go back and get. And again, as a data professional, doing things like cleverly derived new variables like this RFM analysis here that Ari Moses it used to be just down the hall, helped me create this very clever sort of way of capturing the frequency, the recency, and the monetary value of each customer, and adding in just yet another variable into my algorithms for consideration of which customers are likely to default on a loan or upgrade or buy a hybrid car or whatever. And as you go through this and you get more and more into it, you start saying, well, I started out with 20 variables, but I got curious and I kept on thinking about it. And I got more and more data because I allowed the data science, the data analyst inside the database where all the data is, and I can go get some more data. I might even get a lot of data, but the right data, not just throwing data at the wall. And as I look at all the different sources of data with sensors and tweets and Hadoop data and all over the place, I have just lots and lots of possibilities here. But the most important thing, this is why I'm excited for data professionals, is the engineered features, really figuring out what are the most important variables that really have the best potential information to send into the algorithms. Now we're up to modeling, okay? So now I'm going to take my historical data, I'm going to take a certain amount of it, and what we'll do automatically, or you do in your scripts, is you'll take typically a 60% sample of that data. So we're going to take a sample of the data, we're going to build some models on that, and then we're going to test the model against a holdout sample, the other 40%. So that's how we know how accurate the model is, and we can evaluate it. How good is this neural network, this naive Bayes, this random forest, wherever I can compare the accuracy of each of these models, all using the power and parallel processing of the database, the security, the encryption. But that's what's going on, right? You say I want to have a business problem, I have a bunch of historical data, I build a model on a certain amount of data, I test the model to see how accurately it can predict the past, and I come out of it saying, hey, I got a pretty good model. So now maybe I want to, apply that model. With the Oracle Autonomous Data Warehouse, we have a number of different templates. Most of what I've been talking about are these ones, the attribute importance and the classification one. You can just take these templates, import them into your own space, and keep right on going. And what I'm going to do is walk through a few notebook sequences here and more to kind of show you a little bit more of that. So here we're building a model. We're beginning DBMS DBMS predictive analytics, kind of another way of calling it, is doing an attribute importance, and we're finding the key variables. Here we're doing that. Remember that split it into train and test. So under every good GUI is code. Here's the code, and we provide the templates for that. Now we're also adding more automated GUIs and so on. But here is where we do the 60-40 split, and here's where I build the model, and here's where I do the test model and get the results. And when I'm done with that, Oh yeah. Also, you don't have to write code. There is hope coming. There's something called the Oracle Machine Learning Auto ML user interface that uses a lot of our new Auto ML capabilities, and we put a nice, easy to use GUI there. And there's a lot more to go on to that. But in the Auto ML, I just kind of define the business problem. It launches many different models. It does the attribute importance, shows the results, and so on. And Auto ML is coming in early 2020. So again, this is all on the autonomous data warehouse as part of the Oracle Machine Learning offering there in the cloud. Also in model evaluation, you do things like lift charts and confusion matrices. This is something I think the data scientists sometimes make it a little bit more complicated than it needs to be. But the point is, you found patterns in the database, you want to apply those patterns and make predictions. So now you want to apply it. So here we're saying, well, I've got a model apply. So I'm trying to do some sort of scoring function. I'm going to make leave all these predictions in the database. The whole build and apply all inside the database, very, very sort of straightforward and accelerated, right? Very, very fast. So here's another one where I'm doing a whole application for finding a fraud. So I set up my settings. I build the model for anomaly detection. I then say, show me the top 5 most suspicious claims. There they are. I can just automate this, schedule it, put a GUI around it, whatever you want to do. I really think that we've turned the database into sort of analytical clay that you can build into whatever kind of structure or shape or object you want these days. It's very, very, I think, interesting. Here is, I've been working with David Peak a little bit from the Apex team, and here we're saying, well, all these results are in the database. It's pretty straightforward. This is a nice little simple scenario for predicting a good bottle of wine, less than or greater than 90 points wine. So we're looking at, these are all the less than ones. I guess they should have updated this or done the sort, but we're looking for the good wines, the greater than 90 points. And you can use Oracle Application Express, show them in graphs, tables, or whatever. The results that we've generated are in the database. So I can also use Oracle Data Visualization, Oracle Analytics Cloud, any of the OAKS family of offerings to show that same attribute importance. Or what I was showing before was a decision tree that showed all the different ways that people could possibly be likely to respond to an offer. Well, now I might more easily, for a better graphic, rather than a complex decision tree, I just might want to show this as a bar chart here. Here I'm showing as a pie chart with the reasons or the rules that we've discovered as the legend of that. So congratulations, you've gone through this whole process in 6 weeks. We've accelerated into 33 minutes here so far, but that's the kind of idea. And I think it's a very logical, approachable path for you. I have one of my customers here, Ta, is one of my proof points. Ta was a self-proclaimed, self-taught BI analyst who was trying to get his job done. The DBA couldn't get him the data fast enough, easy enough, so he said he taught himself SQL. He would go back and do his reports in Apex, things like that, and he wanted to do more with his data, and I just sort of, as they would say, coached him up on how to use both the Oracle Machine Learning notebooks and the Oracle Data Miner drag and drop GUI. And now he's presented at Oracle World. He's presented at our Analytics and Data Summit that we run, and he's just really done some great things. Here is one of my favorite ones, the UK National Healthcare System, where I've worked with these guys to get them up and going. They've done amazing things. They've identified billions of dollars of savings just by analyzing the data using the algorithms that we've brought to the data. So there's a lot more on that one. So why would Oracle be the place to go for this? And I like Larry said this at 2 Oracle Worlds ago, because that's where the data is, right? Where's the data? You need to analyze that data. So where should you start if you want to go down this path? There are some links. We put them in the chat window at the very end. In the chat window, they should be in there. Irvin or someone or I can paste those in again. They're also in the PowerPoint slides here that we will post. And this is our hands-on lab. We ran at Oracle World, so the materials that we use here are out on OTN, and you can in a blog, you can just grab those. The easiest thing to do is just Google Oracle Machine Learning on OTN, and you'll get links to everything. You'll see all the Oracle Open World talks, and there's a lot there. Want to always remind everyone, this stuff is just available for free. If you just go to this Oracle whatever free tier, whatever you click on these days, you can just sign up an account by the time this webinar is done. You can access this and give it a try. And all those examples I showed are all in there. So just give them a try. And if you have any questions or problems, you can feel free to reach out to me. Always want to highlight our Analytics and Data Summit. I hope you can join. We're still in the early bird registration right now. It's only, I don't know, $400, $500, $600, but it's dirt cheap. We'll have about 500 people out there on the Oracle Santa Clara campus this year. Hope you can join us for 6 different multiple tracks, concurrent tracks, and excellent keynote speakers talking all about just analytics, data, novel and interesting use cases. So please join us for that. And with that, I'll say thank you very much for your time. Thank you for sharing your lunch, your breakfast, or wherever you are with us for these bi-weekly tech casts. And if you have any inclination, you can follow me on Twitter. And with that, I will stop, but I want to turn it back over to Irvin. We'll try to field any questions here, but I also wanted to go back over to here. I think I'm supposed to go back to the TechCast and give a pitch for the next one is Brendan Tierney doing his talk. So that's coming
Awesome.
up. Now I'm gonna look and see if there's any Q&As in here, and I don't see any questions, Irvin. Do you have any questions?
There's a question in the chat window, and I can read the question for you. It's what will be the impact of data science as a service as far as machine learning module creation goes? Would it minimize the coding in machine language?
The impact's profound. I mean, I think in the next 5 years, you're going to, you know, the impact, to me, the logjam for deploying models there, I saw something about big data science projects, 87% of them fail to go to production, get to be operationalized. I think what Oracle have done is like this next generation hybrid data management and combined machine learning, whether or not you're using a GUI or code or whatever, the main point is the data and the algorithms are in the same, you know, place. They're not two different, you know, places. They're in the same place. And so I think that everything you see in science fiction movies about this kind of stuff, I believe. I think it's all very possible and probable. Any other questions?
There's one more, and that question is there any certification track for this and corresponding training?
Well, but as I said earlier on, there's the hands-on lab, there are the tutorials, all of these, so this talk is recorded and so on. So there's a plethora of different resources and tools. I am working with Oracle University, who are codifying all this together into a 2-day course. We don't have a date on when that would be available yet, but it is something at the Analytics and Data Summit, we will have sort of a, you know, some compressed versions of that going on. So we're working on Oracle University is working on them, trying to support them in that creation.
Oh, thanks, Charlie. And we'll do one more, and this will be the final one.
Yeah, and we probably should wrap it up to keep everybody, yeah.
Speaking with some data scientists, they seem to suggest that DBAs do not have mathematics, statistics, and algorithm knowledge to understand ML problem solving. How do you respond to that?
I think some DBAs probably don't. Some DBAs do, right? As I've always said, you know, if you know that my rubric or my litmus test is, do you know the difference between a mean and a median? And if you say, yeah, of course, I know that, and that means you're sort of analytically aware, and you know what a correlation is, and the whole thing about that's why I went into my background. Years ago, it used to be you had to be a statistician, you had to have a PhD in it. Now, you know, with machine learning, it's sort of like, you know, we talk about algorithms, I'm going to develop an algorithm. No, Oracle's developed the algorithms. They're part of the database. You just need to apply the algorithms as a machine learning function for classification or regression or whatever. So yeah, you can, you know, but we're doing auto ML too. So in auto ML, it'll be something that we've worked with Oracle Labs on, and we're implementing in the 20C database and so on. In auto ML and in that new user interface I showed, I teased, you'll say, here's my business problem. Here's the data I want to send up to it, and the auto ML will automatically sort of run a shotgun approach to run out all the different model types in a much more intelligent way, do elimination of features that don't make any sense, and hyperparameter tuning, and it'll do all of that automatically for you. And so at a certain point, it's like, you know, yeah, you used to have to do a stick shift and know when to clutch, and you had to have a master's or a PhD and all that, I imagine. But nowadays, the whole concept of machine learning is it's much more automation. So it never hurts to have a PhD in this stuff, but I'm saying my experience is I've had it far easier for people who know the Oracle technology and all the vast power and capabilities of the database to incrementally add a machine learning than it is for a person who knows machine learning in Python, Scikit, or anything like that, and knows nothing about the database, for them to know all about the implications and the power of the database. So that's why I think this is exciting.
Awesome. So we do have some more questions, but we're going to have to end the questions at that point. I do want to encourage anyone who'd like to present a TechCast themselves. If you have some idea that you may want to go over, Charlie or myself or some other member of our team would be happy to go over your ideas with you and help coach you along to present a TechCast in the future. Our TechCasts are generally 30 minutes long. We can go a little bit over with our questions and answers, but that's where we like to keep it. I think that with that, we can end our TechCast for today.
Thank you. Thank you, everyone. Thank you, Irvin, and thank you, everyone.